short for properties, they are read-only properties that are shared between components. A parent component can send data to a child component. When you include a component within a parent, you can send that child component key-value pairs. In the last video, we made cards, but all of our cards were identical. Using props, we can send a child component individual values so that they're all unique. Let's go over an example. But all of our cards were identical. Using props, we can send a child component individual values so that they're all unique. within our app component, I will create a new component. Let's go to our source folder, go to new file. We will create a component. students to display student data. Student CSS. We need to create a function student, parentheses, curly braces, then don't forget to export default the name of the component, student. In order for this component to accept props, this function needs a props parameter. Props is going to be a JavaScript object. So let's add our return statement. We'll include a few HTML elements. We'll start with a div. Within our div, I will include a paragraph element. Within our paragraph, we'll add the text name, colon, space. We'll include a set of curly braces to inject some JavaScript. Let's take our props, this is an object, access the name property. However, we still need to pass in a value for the key name. So heading back to our app component, we need to import the student component. Let's do so at the top. Import student from the location where the student file is found. /student.jsx. Let's include a student component within our app component. Student. Now, if I would like to send some data to my student component, student is going to be the child in this case, app is the parent, we'll need to list key value pair. be name equals some value. For the value associated with the name key, let's say SpongeBob. When I save and update everything, we have the name SpongeBob. When we send key value pairs to a component, they're all stored within this props object. To get the value associated with the key, you type props dot the name of the key. That will give you the associated value. On my webpage, I'm going to zoom in a little bit just so you can see it. That's good for now. Heading back to our app component, let's send another key value pair. Let's send an age. If you're going to store some data as a value, if it's not a string literal, you gotta enclose it within curly braces. Let's say SpongeBob, his age is 30. We now have access to this age key. Heading back to our student component, let's create a new paragraph. Age, colon, space. To include some JavaScript, we gotta use a set of curly braces. We are accessing the props object, dot, access the key of age. SpongeBob's age is 30. Okay, let's send is student. Is SpongeBob a student? We'll create a key. Of is student equals, add a set of curly braces, is student will be a boolean, true or false. SpongeBob is in boating school currently, he is a student. Let's save. Heading back to our student component. I'll include a new paragraph. Student, colon, space, curly braces, props dot is student. SpongeBob is a student, that is true. However, our boolean is not displaying. So with a boolean, I recommend using the ternary operator. is student within props is true, then we'll return a string literal of yes. Otherwise, we'll return a string literal of no. Let's up. Everything? Yes, SpongeBob is a student. You can place complex JavaScript code within your HTML code. Booleans don't display directly to the DOM. You typically find them used within ternary operators or some sort of conditional. If some value is true, return or do this. If not, do something else. Now, if I were to pass in a Boolean value of false, well, that will change to no. SpongeBob is not a student. Let's change that back to true. Now, before I include a few more components, I'm going to do a little bit of CSS styling, just so that all of this is going to be more readable. I'm going to zoom out to 100%, where it was originally. Within my student component, within the enclosing div element, I will set a class name. Remember that with JSX, you have to use class name, not class, because class is a reserved keyword. Let's name this class student. Then heading to our CSS style sheet, index.css, feel free to clear out anything within here. I will select the class of student. I'll change the font family to be Arial. I'll add a backup of sans serif in case Arial can't display for some reason. Let's change the font size to 2EM for 200%. I'll add a little bit of padding, 10 pixels. I'll add a border. Border, 1 pixel solid. Pick a color. I like HSL values. I'll set the transparency down a little bit to like 80%. Let's go with like 50% lightness. I'll remove any margin around the paragraph element. student, then access any paragraph elements. Margin 0. Okay, that's not too bad. So this is a student component to display some student data. We'll reuse the student component, but pass in different data each time. We'll create a new student component. The student's name will be Patrick. Patrick's age. Patrick will be 42. Is Patrick a student? Is student. I will set that to be false. Let's update our web application, and there is Patrick's data. Name, Patrick. Squidward's age will be 50. Is student. Squidward will not be a student. That will be false. Then let's add Sandy. She'll be the last student. Student name equals Sandy. Sandy's age will be 27. Is Sandy a student? She will be. That will be true. There we are. All right, we have created 4 student components. Each has different values depending on what we pass into props. We're going to move on to prop types. Prop types. Prop types are a mechanism that ensures that the pass value is of the correct data type. For example, within props we have an age. We would like to ensure that the age value passed in is a number, not a string or a boolean. If it isn't, then React can emit a warning within our console, mostly for debugging purposes. If you're working with props, it is good practice to also use prop types. So here's how to create prop types. After our student function, we'll type the name of the component, student dot prop types equals curly braces. Now we do have to import prop types. It's found within the node modules folder. Where is it? This should be in alphabetical order. There it is, prop types. At the top of our JSX file, we will import prop types from prop types. Prop dash types. Within our prop types, I would like to ensure that any name passed in is going to be a string. If it's not, we'll issue a warning within our console. Name, colon, space, prop types, dot string. Let's do this with age. Age will be a number. Age, colon, space, prop types, dot number. Then is student. Is student will be a boolean. Is student, colon, space, prop types, dot bool for boolean. All right, and those are our prop types. Heading back to our app component, for SpongeBob's age, I don't pass in a number. Let's say I pass in a string of 30. Well, this won't prevent the program from running, but it will issue a warning within our console. If we right-click, go to inspect, go to console, we can see a warning. Failed prop type, invalid prop age of type string, supplied to student, expected number, and here's a location. So this is good for debugging. It won't stop the application from running, just issue. then lastly, we're going to discuss default props. Default props are default values for props in case they are not passed from the parent component. Let's say we create a new student component, but we don't pass in a name. We can add a default value, such as guest, just in case that value isn't passed in one way or another. Okay, let's add default props down here. Student dot default props equals, set of curly braces. For the name, the default value will be guest. Age will be 0. Is student will be false. To test this, let's go to our app component. We'll create a new student component, but don't pass in any props. We'll create an empty student component with no props. That appears to work. The name is guest, the age is 0, student is set to no. So if I were to include a name, let's say name equals Larry. Well, Larry's name is going to be set. We didn't include any key value pairs for age or is student. We ended up using the default values 0 and no. All right, everybody, so those are props. They are read-only properties that are shared between components. A parent component can set student is set to no. So if I were to our app component, is student will be
most reusable components on the page. The project we'll be building in this section is going to be a travel journal. And the primary thing that will make it different from the static page that we made in the previous section is that all of the information that we see on the page is actually going to be contained in a regular JavaScript file in the form of regular objects and arrays. This is the completed project over here, and you can see that we have this data.js file where all of the information lives, and then the React code that we write will take this array, iterate over it, and produce React components with that information inserted in the correct place. Feel free to peruse around this code to see if you can get a cursory level understanding of what's going on. And as always, you can click on the screenshot you see here to take you to the Figma design so you can be prepared to start building this project based on the real colors and spacing that are defined in the Figma file. In this section, we are going to be learning first, of course, why reusability is important, and we'll recognize that it's actually something that you are exposed to in just about every website you visit. Then we'll dive into the syntax for the primary vehicle for doing reusability and data-driven React components, which is something called props. Then with an understanding of how props works, we will create components from an array of data, just like we were talking about earlier. And of course, this wouldn't be a real Scrumba course if we didn't include a ton of hands-on challenges along the way. So warm up those fingers, get ready to complete all of the challenges in this section, which is what we'll be diving into right away. With the basic concepts and syntax of building static, we'll start working on this section project of the We'll start working on this section project of the travel journal by having kind of a softball challenge. This will mostly be review of the things that we've learned previously. Our task is simply to make this header section for the travel journal. The first thing you should do is click on the screenshot here. That's going to open this design in Figma so you can see the details for this design. And I've tried to set you up for success with this project by including a fairly detailed description of the task at hand. A couple things that I have done already for you. If we look in our index.html, I've pulled in the Google font of Inter, which is the font that you'll see is used here in the design. And then I've also pulled in this little globe image just right here as globe.png. free to style this however you want. You can use class names, or because this is a relatively small app, I'm okay if you want to use some element selectors. Assuming you're using some good section 1, this will be handed over to you.
from Create React App, a widely used tool that's reliable but somewhat dated. Many companies still use it, but it's not the most modern option. Vite became a new norm and industry favorite, celebrated for its lightning-fast HMR, optimized builds, and speed. It's an excellent choice for quickly setting up a React app, and you can set it up manually. If you're someone who loves to spend a lot of time doing manual setups so you feel like you're a great developer, then you can do that. Just kidding. All I meant is that you can also manually set up a React app using Webpack and Babel, or directly install React and React DOM in existing projects. But why reinvent the wheel when somebody already created a rocket? Head over to Vite and notice that you can very easily create a new React application through a single command. We'll do it that way to get faster build times, improved performance, and modern tooling. So simply copy this command, open your code editor with an integrated terminal, and paste it. It'll ask you whether you want to install the package to create that React app. So say Y, yes, and it'll ask you for your project name. Let's do something like my first React app. Choose React, and choose JavaScript. Later on, we can do some TypeScript too, but for now, we'll stick with JavaScript. And there you have it. The entire project got generated in just a fraction of a second, probably before you even had the time to blink. Now, let's actually see which files and folders have been generated and for what reason. Starting from the bottom to the top, first we have the vconfig. This file allows you to customize the build process, such as adding plugins, configuring server settings, and more. It's optional for most basic projects, but can be useful if you need more advanced customization. After that, we have a readme.md file, which contains the information about the project, like how to run it, what the project does, and other documentation. And the package.json contains the metadata of our project, such as its name, scripts, and dependencies needed to run it. The dev script starts the development server, while the build script creates the production build. You can run those commands by opening up your terminal and running npm run, and then the name of the command you want to run. But before you do that, first you have to install the necessary dependencies to be able to run the application. You can do that by running npm install, or for short, npmi. Or in my case, I don't have to type anything, as WebStorm immediately asked me whether I want to run npm install. So that's exactly what I'll do. There we go, the packages have been installed. Since WebStorm did it for me, I didn't have to worry about switching directories. But if you're doing it manually, you first have to cd, change directory, into whatever you named your app. So in this case, that is my first React app. And then here, you can run npm install if you haven't already. Now run npm run dev. This will run your application in about half a second on localhost 5173. You can see it live just by clicking on this URL. There we go, a simple app with a counter and a couple of icons. Don't worry, we'll delete all of this soon and start from scratch. But for now, let's move ahead and check out other files, such as the package lock.json. This file is automatically generated when you run npm install. It locks down the versions of the dependencies installed in your project, ensuring that every project installation, whether on your machine or when your colleague or boss is running your application, will install necessary dependencies to be able before you even had a time to blink. Now, let's actually see which files and folders have been generated and for what reason. Starting from the bottom to the top, first we have the vconfig. This file allows you to customize the build process, such as adding plugins, configuring server settings, and more. It's optional for most basic projects, but can be useful if you need more advanced customization. After that, we have a readme.md file, which contains the information about the project, like how to run it, what the project does, and other documentation. And the package.json contains the metadata of our project, such as its name, scripts, and dependencies needed to run it. The dev script starts the development server, while the build script creates the production build. You can run those commands by opening up your terminal and running npm run, and then the name of the command you want to run. But before you do that, first you have to install the necessary dependencies to be able to run the application. You can do that by running npm install, or for short, npmi. Or in my case, I don't have to type anything, as WebStorm immediately asked me whether I want to run npm install. So that's exactly what I'll do. And there we go, the packages have been installed. Since WebStorm did it for me, I didn't have to worry about switching directories. But if you're doing it manually, you first have to cd, change directory, into whatever you named your app. So in this case, that is my first React app. And then here, you can run npm install if you haven't already. Now run npm run dev. This will run your application in about half a second on localhost 5173. You can see it live just by clicking on this URL. There we go. A simple app with a counter and a couple of icons. Don't worry, we'll delete all this soon and start from scratch. But for now, let's move ahead and check out other files, such as the package lock.json. This file is automatically generated when you run npm install. It locks down the versions of the dependencies installed in your project. Ensuring that every project installation, whether on your machine or when your colleague or boss is running your application, will install exactly the same dependencies, making sure that your app runs perfectly. Don't delete it. After that, we have an index.html. And this is the main HTML file within which your app is loaded. It has a basic structure, including the root div, which React will infuse with your entire application. Vite uses this as the entry point. And there's also the script that points to a main.jsx file, which initializes your application. We'll check it out soon. For now, let's continue up ahead to ESLint config. This is a config file used to define the rules and settings for ESLint, a popular linting tool. It helps you identify and fix problems in your code, such as coding style violations, errors, and potential bugs. After that, we have git ignore. This file tells Git which files and folders to ignore when committing your code. The most important thing to ignore are files and folders to ignore when committing your code. The most important thing to ignore are node modules. You never want to push these over to GitHub. Rather, you want everybody to just get your code, and then if they want to, they can just run npmi. And the second most important thing to ignore is the .env file. which contains your environment variables. Those need to be kept safe. Some of the other folders on the list include node modules, which contains all the installed dependencies for your project. Everything from React, Vite, and more. This folder is huge and contains even more folders within it. You never really have to get into it. It's just there for your app to work. It's completely managed by NPM, and you don't have to interact with it directly. After that, we have the public folder, which contains static assets, such as images, icons, and other files that don't need to go through Vite's bundler. Files in here can be referenced directly by their path, such as /vite.svg. And finally, we have the source folder. This is where your React components and JavaScript logic go. Tailwind CSS will be applied here to the styles you import into your components. App.jsx is where the main UI of your app is defined. Whatever you write here will appear on your website. Main.jsx is the entry point of your React app, where React is rendered into the DOM. You can see that here we use plain JavaScript to get the element by ID of root, and then render the entire app right within. Since this is the entire app, here we import our main style file, index.css, where you can define the global styles of your application. After that, we have the assets folder containing media assets like images or icons, and these can be imported into your React components or used within JSX by simply importing them like this, and then using them as the source within the image component. And finally, the app CSS is the styling file specifically for the app.jsx. As you can see, we're importing it only here. You can create as many CSS files as you want and import them into different components, just to make sure that our styles are tidy and separated. Hopefully, this all makes sense. Sure, there are more files and things happening behind the scenes, but just to make sure React.js runs smoothly, you don't need to worry about those files all the time. Now, before we dive into React.js syntax and learn how to write its code, let's quickly set up something cool for the feature I'll teach you how to build today. We're going to be using AppWrite, an open source backend for your React apps. The link is in the description, so just click it and quickly create your account. We'll use AppWrite to develop a simple algorithm that tracks what users are searching for on our movie app, and then suggest the top 5 trending movies based on their search history. We'll set up our AppWrite project and connect our React app to it a bit later. For now, just creating your account is good. Let's talk about components in React. There are 2 ways in which we can define components. The traditional one is called class components. While they're not widely used anymore, they're still common in older code bases. An example of a class-based component would look something like this. Class component name extends React add component, and then there's a render method and a return statement. All of this code just to be able to return a simple H2. You might encounter these if you work on larger projects in big companies. However, for new projects, they are no longer recommended. Instead, there's a better way to create components. Components just like this one right here, where you define it by just declaring a JavaScript function. But we have a lot of unnecessary code right here. So let's actually delete this entire function and create it from scratch. You could do something like function app, or you could also use newer JavaScript syntax called arrow components. That would look something like this. Const app1 is equal to, and then you declare it like this. I actually prefer this way of creating components, so I'll just call it app, and I'll just export it at the bottom. Then within here, you can say return, render on H2, and say something like functional arrow component. Now, if you head over to your browser, you should be able to see the text we are rendering, which means that the component is showing successfully. And the beauty of creating React components is that you can create as many as you would like. Something like const card component, or just card, would render a little card that looks something like this, card component. And then you can use that card within the original app component by simply wrapping it either in this interesting little component called React fragment or just a regular div. And then below the H2, you can render as many card components as you would like, just to write code only once and use it multiple times, eliminating repetition. And that's the power of React's component-based architecture. But of course, it'll start making much more sense as we dive deeper into some more real React apps, so I can show you how real developers use it on their day-to-day projects. But writing components is not enough. Sometimes we want to pass data from one component to another to display something specific and not create multiple similar components for every little change. And we can do that through props. In React, props, short for properties, are a way to pass data from one component to another. You typically do it from a parent component to a child component. Think of props as arguments you pass data from one component to another. You typically do it from a parent component to a child component. Think of props as arguments you pass to a function. Let me quickly show you how it works in action on our current example. Let's say that each one of these cards renders a different movie title. Later on, it can also be a thumbnail, title, description, and more. But for now, let's say it's just the title. You can go into that card and then pass something known as a prompt. Let's call it title and make it equal to some famous movie title. Let's go with Star Wars. The second one can be something like Avatar. And for the third one, maybe we can do something like The Lion King. Now, if we do that and save, you'll notice that no changes have been made to our app. They're all still the same. Card component. Well, now we can put that prop to use by heading over to our card component and accepting that prop right into it. We have to call it title and destructure it. And then instead of rendering the card component text, we can dynamically render the title that is being passed into the card, resulting in different text for each one of these. Pieces of UI. And keep in mind, the prop can be anything. It can be a string, but it can also be something like a number or even a boolean. It can even be a complex prop, which is an object. So in this example, pass some information about the actors, which can be an array of different objects, where we have a name of each one of these actors in a list. You can do whatever you want. And then we need to accept all of those props right here at the top and then do something with them in the UI. Pretty cool, right? Well, we're just scratching the surface of what React is capable of. So far, you're doing well, but this is far from ideal. This is looking very plain. Just text on the screen. We need to give it some styles to offer a good user experience to the users. So how can we apply styles in React? Or maybe I should rephrase. Is there any kind of styling we can't use with React.js? Inline styles, CSS, Tailwind CSS, Bootstrap, Material UI, and UI, Sass, CSS in JS, CSS modules, you name it. You can choose any approach to style your React apps. So let's try a couple of these styling ways in our app. First of all, head over to index.css and remove all styles from here. This is one way of styling, where you write styles in a separate CSS files and then you import them into your component. We've imported this index.css file within our main.jsx. Let's start by applying some styles to this app. I'll start by targeting all the elements and set some styles that you typically do at the start of every single application. set to 0 and padding set to 0. This will reset those styles for all the elements of the screen. Next, we can target the body element and give it some padding, like 40 pixels should be enough. Oh, and I almost thought that I was writing CSS in JS, so I automatically made it a string, but that's not necessary in regular styling. We can also change the background color to something like #151515. Let's also change the font family to something like Franklin, Gothic, Medium, or if we don't have that, we can just do Arial. And finally, we need to style the H2 element. By changing its color to something like #F. F3, F3, giving it a text align off center, as well as a margin bottom of about 30 pixels. And finally, a font size of 48 pixels. There we go. Now I can zoom out a bit. And we can see everything more clearly. We just applied some styles directly to HTML elements without having to manually select them right here. But if we want to be a bit more specific, then we can use class names. So let me remove this first H2, and let's remove some of these props as we're not using them anyway. And now we can give this div that's wrapping these three cards a class name equal to card-container. Notice that unlike styling HTML, you don't have to say class name all lowercase. In React, it actually has to be uppercase N in class name. Now you can head back over to index.css and style that class name by saying .card-container, and then you can give it a display flex. And style that actually has to be uppercase N. dot card container, and then you can give it a display flex, flex wrap of wrap, justify content of center, as well as a max width of something like 1024 pixels. This will make it look good on all different devices. I'll also give it a margin of 0 and then auto. And naturally, if you apply an ID to this div, you would be able to style it by saying hash and then the name of the ID. Now that you know how we can use external style sheets to style our React components, let me also say saying hash and then the name of the ID. Now that you know how we can use external style sheets to style our React components, let me also teach you how we can do some inline styles. We can do it on this card component by giving this div a style property and an object, and then here you can define styles within JavaScript by saying, for example, border is 1 pixel solid, and then we can do hash 4b5362, and now each one has a border. We can give it some additional padding of maybe 20 pixels. Let's give it a margin of 10 pixels as well. A background color of hash 31363f. And notice how if you're using inline styles within JavaScript, you cannot say background dash color. It's actually using camel case, background color. Let's also give it a border radius of something like 10 pixels. And let's also give it a min height of about 100 pixels. Now, what would happen if we mixed match both the styles from the external style sheet and internal ones. Let's add a class name right here, equal to something like a card. If you now head back over to index.css and define the .card class name, and give it something like a border of 2 pixel solid red. Oh, again, I'm using string signs here where I don't need to. You can notice that the color didn't change. That means that inline styles have the preference over all the other CSS stylings. So do remember that. But it's always better to stick with one way of styling anyway. And in today's world, Tailwind CSS is the way to go. It's the preferred way of styling apps of any kind. So in this tutorial, later on, once we actually start building your movie application, you'll use the most popular and most in-demand way of styling applications through the latest version of Tailwind CSS, version 4.0, which was released exactly at the date of publishing this video. So you know that with JSM, you're always getting the latest information. Now let's quickly fix up our styles by heading over to the index CSS and removing this margin bottom from the H2. We don't need it. And now all of our cards are looking good. But remember, I already told you that it's always best to use one way of styling. So in this case, I will remove these inline styles and I'll move them over to our external style sheet. So let me copy all of this and exchange it for a class name of card. Then we can head over into our index.css and paste all of those styles here, but you'll have to change it to use lowercase letters and dashes in between. So border radius, background color, and min height. And at the end, you'll have to add a semicolon. And of course, remove all the string signs. We don't need that in native CSS. So let me quickly do that, and we're good. Everything still works as before. And with that, we are ready to dive into what I believe is the most important concept in React, called the state. State is like a React component's brain. It holds information about the components that can change, called the state. State is dive into what I believe is the most important concept in React, called the state. State is like a React component's brain. It holds information about the components that can change over time. In this code, for example, if you have to track if someone has liked a movie or not, you'll have to use state. If you use a regular variable, something like const has liked and set it to true, and then use it right here as a prop, has liked is equal to has liked, well, this won't work because React won't know that something has changed and it won't update the DOM accordingly. That's because React's rendering process relies on state and props to decide when and how to re-render the components. So let's create a state that allows users to interact with each card and allow them to like or dislike that movie. I'll start by heading over to our primary application and define our first state by saying const, and then you have to destructure an array like this, and then make it equal to a call to the useState hook, which you have to import from React. So right here at the top, import useState from React. Keep in mind that in React, everything that starts with the verb use typically is referred to as a hook, and React has many different hooks at your disposal to allow you to build your applications more simply and more scalably, React being one of the most important ones. And the way in which the use state works is that you first destructure the actual variable name. In this case, we can name it has liked, a Boolean variable in this case. And then as the second parameter to this destructured array, you can get a setter function that you can use to update that state. So in this case, set has liked. These are names that I just thought about on the spot, but you can follow this similar pattern. First, you give a variable name. It can be anything. And then you say set, and then use the same name. This is the common practice. For now, I said has liked and set has liked, but we're not yet done. Within the parentheses, you can also provide the default value of that state. In this case, the state is a Boolean, so I'll say that at the start, the initial state of this has-like variable will be set to false. And as you can see, I'm using WebStorm as my IDE, so it intelligently recognizes what this first parameter to the use state is, and it is the initial state. Of course, if a variable was something like a number, then of course you could set a 5 or 10 or any kind of value, or a string, or even a complex object. All of that is possible. Now, right within each one of our movie cards, below the title, let's implement a button. A button that will allow us to like a movie. This button will say something like. And it'll have an on-click listener. Within here, we can define what happens when this button is clicked. We'll define a callback function within it, meaning that once this button is clicked, this function will be executed, but more specifically, whatever is right here, either within this curly braces or after the arrow function will be executed. In this case, I simply want to call the setHasLiked function, and I want to set it to true to be able to like it. Now, as you can see, if I hover over this, it's going to say unresolved function, because within the scope of this card, we haven't yet declared this setHasLiked state. It is declared within the app itself. And this is where the beauty and the complexity of React come. Deciding on where you will define which piece of state. If the state has something to do with all of these three cards, maybe something like hide all movies, and then that can be true or false, well, it would make sense to have that state right here within the app. But in this case, this has-like state will be different for each one of these cards, so it makes more sense to take it away from here and add it to the card. Now, if I save this, you can see a little like button appear right there, but let's also liked state will be different for each one of these cards, so it makes more sense to take it away from here and add it to the card. Now, if I save this, you can see a little like button appear right there. But let's also style that button further by heading over into our index.css and just styling all the buttons on the page by giving them a border of none, a font size a bit larger of about 30 pixels. Once again, I'm used to writing CSS in JS, so I'm used to this different type of syntax. And I think that just shows you that later on, once we develop this movie app, you'll learn a whole new way of writing styles, which is much better and much faster than this one here. We can also change the background color and make it transparent. Let's give it a width of about 100%, as well as a text align of right. And I know that this doesn't matter too much to teach you React, but I still want to make sure that you can visually see what this app is about and how all of these features interact with each other. And we can give it a cursor of pointer to know that this button is clickable. That'll look something like this. And now, if we click like, we cannot really see that anything changes, right? So how can we change the UI depending on the state? Well, you simply do some conditional logic. Instead of simply always saying like, we can do something like this. Open up a new dynamic block of code similar to what we did with the title. So whenever you want to render just regular text like this, then it'll always say title. But if you want to use some dynamic variable, then you put it within curly braces, and that'll make sure to make it dynamic and render the data of the variable that we're trying to render, not just the title text instead. So here we can check if has liked is true. And if it is, then we can say liked, else we can say like. So now for the first one, you can already see that it says liked, even though it's not that apparent because it's black. But you can see that now I can click on all of them and they will all say liked. And they'll stay that way until I reload the page. So that is a very important thing to mention, that the state is not persistent across browser reloads. As soon as you reload the browser, the component will get re-rendered and the state will return to its initial values. Now, instead of just saying liked and like, we can show some different kinds of hearts, just so it's easier to visualize it. And now think about it. How would we unlike something? That's a good question, isn't it? Currently, we're always setting the has liked state to true. How would we figure out if the state is already liked and then flip it like a switch? Well, you can say set has liked is equal to not has liked. So turn it around and flip a switch. Now, if you click on it again, you can see that we can like and unlike it, and it happens instantly without a browser reload. That's because when the state changes, React automatically re-renders the component to reflect the new data on the screen. In this example, initially, hasLiked starts as false. Then we have the setHasLiked function, which is used to update the state. And when you click the button, it flips the switch to set the state to the opposite of its previous value. React then re-renders only that card component. And that's the beauty of React. Like, Like when you click and change this state, it only changes this one, and it doesn't. doesn't touch any other cards or elements on the screen. And then the updated has-liked value is used to display either a red or a white heart. But if we kept the state within the app and passed it as a prop, we wouldn't be able to like or unlike each card separately. Having it here allows each card to manage its own state independently, making the component reusable and isolated. I hope this makes sense. The syntax we just used with useState, and as I told you when I introduced isolated. I hope this makes sense. The syntax we just used with useState, and as I told you when I introduced this hook, useState is just that, a hook. Hooks are special functions in React that let you tap into React features, like state management in this case. And there are many different types of hooks. useState for managing state, useEffect for handling side effects like data fetching, useContext for sharing data across components, and useCallback for optimizing callback functions. There are plenty more as well, and we'll go over some of these in this crash course. But if you're looking to dive deeper, I've covered all of them in detail, one by one, in my React.js Pro course, complete with practical examples, when to use them, and why they're helpful. You can find a link to that in the description if you're interested. But for now, let's move over to the second most popular hook, useEffect. useEffect is like a special tool in React that lets you do things outside of just displaying stuff on the screen, like fetching data from a server or doing some cleanup after the component is removed from the screen. Let's say you want to log a message every time a user likes a movie. To track that, we can use the useEffect. So let's modify the card component to implement it. Right here, below declaring the useState, I'll say useEffect. Something like this. And then I'll import it right here from React, right next.
again. We're going to save this and have a look. So look at this. Ingredients, okay, it is using for you. There's an extension for this. We can search for Tailwind in right now. Well, this is actually a new window different from where we are communicating into Copilot chat. So we can close this right now. We have this one. I'm going to close this PowerShell terminal and I can expand this on a full screen. And now I have also Copilot here and I can use that. Now let's open terminal by hitting Ctrl and tilde on your keyboard, or you can always turns into the entire. So the first line says hello the code, the second line says hello 7 or UL, and I'm going to put this second time with a different name, Zura. So we save this and let's have a look. Now we see hello John and hello Zura because we're executing this function twice with different names, and the function is actually returning a string. However, that function can actually return another JS6. It might be button, it might be like section element, it might be, and AI engines actually yet don't know about this. So they will give you instructions of the old Tailwind CSS, and we can see that in it. Now let's start talking about components and also start heavily using AI to generate some code in our project. I'm going to undo this. I'm going to return this into app component of the card. Before we hit this keep button here, we can review the changes. Right here we see app.jsx file, and this is the current file context. So by default, Copilot adds this file into the context. So if we close this, now nothing is added. If we want to add a specific file, we can click this add files into Copilot, and we can choose a folder or file. We can type app.css, app.jsx, click on this, and we're still adding app.jsx, which we can of course remove as well. If we want Copilot to start working on the entire code base, we're going to hit this code base here. And now, whatever we tell Copilot, it's going to consider the entire code base project to make some changes. So in this case, I want to only use app.jsx, so either I'm going to add from here, or the idea will be if I open that app.jsx, it is going to be added automatically here, and I want to ask Copilot right now, I want to create meal searching app. At this point, just give me a single meal card with image, title, and description. We're going to also be specific. Use Tailwind CSS and nothing else. Let's see what code it's going to use. Now, it's generating these edits. The edits have been done. The file is unsaved, so at this point, if we check in the browser, we're not going to see any changes. All right, save now on this file, and now let's see the browser, and we see this is a card. The image is of course broken because we don't have that image, but that's fine. So we have the title, we have the description of the card. Before we hit this keep button here, we can review the changes Copilot made. If we don't want, we can hit undo. If we want, we can hit unkeep. If we have a look, so we see
to useState. useEffect has the following syntax. You first declare a callback function called the effect, and then within it, you put the code that you want to have executed. Something like title movie has been liked or disliked. So if I save this and open up the console in the browser, you'll see that we have quite a few console logs. 2 for each one of these movies. Why do we have so many? Well, it's because this card component got mounted 3 times. Once for each one of these movies. But wait, something is not right here. Instead of 3 calls, here we can see 6 different console logs, which means that this useEffect has been called 6 times, even though we only have 3 cards. Why the duplication? Have we done something wrong? Well, not really. If you check out the React.js documentation, you'll see a question that says my effect runs twice when the component mounts. And that's normal, because we are in the development mode. When strict mode is turned on, and in development, React runs setup and cleanup 1 extra time before the actual setup. This is a stress test that verifies your effect logic has been implemented correctly. This is not a problem because once you deploy your app to production, it'll only run 3 times. But if you want to learn more properly how React really works in production, you can head over to main.jsx and then remove this strict mode wrapper. This will make sure that there's no duplication. So right now, you can see that there's 3 console logs, 1 for each one of these cards getting mounted to the UI. But now, let's say you want to track the activity of the user for some kind of an algorithm that we might want to develop within our movie app. You want to track the number of clicks to each one of these cards to be able to recommend similar movies. To do that, we'll need to create a new state. So simply say use state, and this time I won't simply start typing it. Rather, I'll press enter to select this template, allowing you to just type your word, like count in this case, press tab, which will automatically write set count to provide the setter for that count variable, and then tab one more time to define the initial state of 0. Since in your React applications, it is normal to have multiple states per each component, using this quick start is always helpful. Now that we have this state, let's create an on-click handler on this card. So whenever we click on the card, we want to set count to be increased by 1. So we can say take the current count and increase it by 1. Now there's one quick thing I want to point your attention to, and that is that in more complex interfaces, it is never recommended to update the value of the state by using the state itself. Rather, what you'll often see being done is you create another callback function without the setter state call, and then you get access to the previous version of that state. And then you can do whatever you want with it, such as do pref state plus 1. In a similar way, here you can get access to the previous has liked and then toggle it on or off. But for simplicity's sake, I'll keep it right now, just count plus 1. Now let's display that state somewhere. We can display it right here next to the title. So let's say title, and then maybe show the count. If you do that, you'll see Star Wars 0, Avatar 0, and so on. Maybe we can add a break tag right here to display it in a new line. There we go, that's a bit better. And now if I reload, first of all, you can only see 3 different renders. But now check this out. If you click on a movie, the number will increase. That's good. But if you keep clicking on it, even though we're not changing the liked state, this useEffect will keep firing. You can see that by this number right here. So every time I click something, we're firing a new useEffect, even though we're not changing the liked state. That's not good. That's not the behavior we want. So let me show you how we can run the useEffect only when something changes. To do that, you can use something known as a dependency array, which you pass as a second parameter, also often called deps. Whatever variable you pass here, React will try to recalculate and then see if it has changed. And only if it has changed, this effect will be called. So if you do this and reload, now if you continue clicking on it, you'll see that our card will actually update, the count state will change, but this useEffect won't run. But as soon as you like or unlike a movie, it will immediately change its state. Pretty cool, right? And can we have multiple useEffects in the same way that we can have multiple use states? Well, surely. And let me show you another most common use case of a useEffect. You can just create it like this, provide a callback function, and then provide an empty dependency array. This is, in my opinion, the most common use case of a useEffect. This is a useEffect that runs only once on the mounting of that component, only when that component first appears. So let's add a quick console log and say card rendered. If you do that, you'll see 3 card renders. This is how useEffect manages the side effects based on the dependencies that you provide. Now we can remove that, and instead of that, I want to teach you something else, something called conditional rendering. Technically, we already learned a bit about conditional rendering when we use this ternary operator right here. Conditional rendering allows you to show different kinds of UI on the screen depending on different criteria. For example, if you only want to render the count if it's not equal to 0, then you could say something like if count exists, then render the count, else render a null. Or in this case, you could just say count or null. So now you can see that it gets hidden, but as soon as you increase it to 1, it's shown. We just implemented conditional rendering. Another way where you conditionally rendered something were those 2 different cards. You can see, now you see one, and now you see the other. Of course, this has been just the simplest example of conditional rendering. Throughout almost every single more advanced application that we build on this channel and on JS Mastery Pro, you can see different cases in which we use conditional rendering. You'll also use it very soon when building your movie app. So with that in mind, let's delete everything that we have right here in our app, and then we'll have to create it once again from scratch. But isn't that going to take a lot of time to recreate this function for every new component? Well, thankfully, there's an extension that helps with that. No matter which code editor you use, you can head over to the plugins or extensions and then find some kind of a package that does React snippets. Install it. And once you do, you'll be able to run RAFCE. This is a shortcut to quickly create a new React arrow function component with a default export. Pretty cool, right? with that in mind, I'm so happy that you're now finally at the stage where you're ready to support. Pretty cool, right? This is a shortcut to quickly create a new React. You'll be able to run React snippets. Install it. And once you do, you'll be able to package that does React snippets. Install it. And once you do, you'll be able to run RAFCE. This is a shortcut to quickly create a new React arrow function component with a default export. Pretty cool, right? With that in mind, I'm so happy that you're now finally at the stage where you're ready to start developing something more serious. You now know what React is, why do we use it, how components, props, styles, states, different hooks, use effects, and so much more work. So you'll finally be able to put it to practice within this amazing app you'll build. So let's dive right in. This is a single-page application where you can view all movies from an external API with pagination. Plus, there's a search feature that lets you find any movie you're interested in. But here's the cool part. We'll simulate Netflix's top trending list. Unlike the movies pulled from the API, these rankings are based on actual user searches within the app. The more users search for a particular movie, the higher its count grows, and the more likely it is to show up as the top searched movie. We are actually building a small algorithm here. We'll do it using AppWrite. So if you haven't yet signed up, now's the time to do so. Just click the link in the description. And of course, this app is fully responsive across all devices. The main goal of this course is to teach you all the most important React.js concepts so you can implement them within your code, within this project, and all of your future projects. Alongside building the app, I'll also teach you how to deploy it to the internet so that everyone can see what you've done. See, the app you'll build today isn't just a project. It's a career asset designed to showcase everything you're capable of, making you an attractive candidate for any job. I highly recommend Hostinger, so I'll put a link down in the description. I'll go with the premium plan as it allows me to host 100 websites with free SSL for HTTPS security, free email for that professional touch, and even a free domain name to give your website a good name. And because I've partnered with Hostinger, you'll get an even bigger discount. Click the special link in the description, click Claim Deal, and add to cart. Choose the period of our hosting. I'll choose 48 months to save the most. And then next to your payment method, you can enter your JavaScript Mastery coupon code, which will give you the biggest discount available. Once you've purchased, we're ready to set everything up. Let's start with Hostinger's guided setup. In this case, we'll create a new website. And we won't use WordPress. We want to have an empty HTML website, which of course will turn into a React website. As you can see, I use Hostinger for all of my domain names. So if you want to choose your domain name right now, you can do that. But if you want to do it at the end, you can click Use Temporary Domain. You can choose the server that is closest to you. And that's it. Our setup is being initialized. While our hosting is setting up, I just want to quickly let you know that there's a GitHub repo containing the entire code for this project. So if you ever get stuck, just make sure to visit the GitHub page and compare your code with the code that's on there. There's also a free complete Figma design for this project in case you want to develop it on your own. And let's not forget the extra lessons and pro courses on jsmastery.pro. With that in mind, our hosting has been set up, and at the end of the course, we'll simply change our domain to a real one and then deploy it using the file manager. With that said, let's dive straight into the code. Now, thankfully, we already have the starter code that we use to learn a bit about React, which we'll use as the basis for our movie application. The only thing you'll have to do at the end is change the folder name. But there's one thing that we don't right now have. Remember how I used to make so many typos when typing out the styles? Well, that's because this is not how we typically do styles in React. We do it using Tailwind CSS. And literally, as of the day that I'm recording this video, a brand new major version of Tailwind CSS, version 4, is now live. It brings much better performance, simplified installation, less configuration, dynamic utilities, and so much more. So in this video, alongside learning React, I'll also teach you a bit about how to use Tailwind CSS with all of its newest features. And if you'd like me to cover Tailwind CSS in more detail in a dedicated crash course, let me know down in the comments, and if many of you comment, we'll do that very soon. With that in mind, head over to the Tailwind CSS website, click Get Started, and then scroll down to the installation using Vite. The only thing we have to do is copy this command, and move it over to our terminal. Now, as you can see, we're already using one terminal to run our application, so we can just create another, which we'll use to install additional packages. I'll simply paste it, npm install Tailwind CSS, and add Tailwind CSS /Vite. And while it's installing, we can check out the second step, and that is to configure the Vite plugin under our configuration. So let's do just that by using Tailwind CSS under plugins under our Vite config, which is right here at the bottom. We just have to add it within our plugins array, Tailwind CSS like this. And we can import it at the top, coming from add Tailwind CSS /Vite. After that, we have to import our Tailwind CSS within our main index.css file. So let's copy this and move it over to our index.css, remove all the other code, and add it right at the top. And that's it. We can start using Tailwind within our code. Let's just copy this H1, head back over to our app.jsx, and use it right here. Class name, text-3xl, font-bold, and underline. If this syntax is looking completely new to you, don't worry, I've already done a quick crash course on how to use Tailwind CSS on the channel before, but by the time you're watching this video, maybe we have a newer one, how these different utility classes work. But in simple simple terms, instead of declaring all of the styles within a separate style sheet, which means that you always have to go here and then open it and then choose a class and then add it, here you just declare a class name and add these specialized utility classes. So it's not, for example, color and then red. Rather, it'll be something like text-red-500. And there's even a Tailwind CSS extension, which will tell you exactly which CSS properties that class is applying. We can also change the font a bit by heading over to our index.css. Within here, we can import different fonts. And the imports for them look something like this. It's a long string of characters that brings in different font that you can use from Google. Instead of having you manually type this out in the GitHub repo, give it a star by the way, you can find a complete detailed README where you'll have different code snippets. So head over here, find the index.css, and simply copy it and paste it in your file. Here, you can find some utility classes that'll make it easier for us to add different gradients, or just apply some styles to images, inputs, and more. And we're also importing the fonts that I talked to you about. You can see that there are some warnings right here pointing to unknown rules for Tailwind CSS directives. That is totally okay, as these are new. It is possible that our IDE didn't yet recognize them, but these are just warnings and everything should work fine. Once you apply those styles, you should be able to see that our app will now get this nice dark mode. And as I said, if you'd like a detailed start-to-finish tutorial on the latest Tailwind CSS version 4, covering how it works, its features, and the best ways to use it, let me know in the comments, and I'll create a crash course for you soon. Now we can finally start with the app. Let's start from the top down, from the header, by turning this entire div into an HTML5 semantic main tag, and then
thank you guys for watching. We shall be there again tomorrow to another live where we shall end. I don't know if anybody has a question, so we'll just try and answer the question very fast. Because yeah, I think that there are 4 people watching me. I don't know if you have a question, anything. Someone asked me like he does not know which back end language he should learn. Normally, to learn a backend language, you first of all have to ask yourself. Yeah. No, he was asking that. Let me just unpin this thing, unpin the chat. Okay, chat. I'll just try and answer the question. So someone just asked me that what is the question again? That he's confused to which language he will learn in DSR, and I already have learned like okay, before choosing a language to learn data structure and algorithm, I'm thinking that it's about to do this leak code grind. So before learning any of those things, you first of all make sure that you know in which domain you want to work in. For example, if it's maybe you want to do in cybersecurity, but basically based on what you have learned, I can determine that you want to do in web development. So you started with front end, that is CSS, HTML, and JavaScript. So if you want to continue in front end development, I will recommend you to choose a language like JavaScript. If you want to be basically a good front end developer, like JavaScript, you start grinding this leak code stuff. But if you want, you should have to choose a back end language, and depending on the language that you choose, either Python,